The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, wherever you are in the country. It's Mark from SolidCAM. We'll be doing our 30-minute free training today. With me, as always, is Kevin Rankel. Hey, Kevin.
Hey, how's it going?
Good. Hope everybody else is good. It's Thursday, so we got today's class and tomorrow's class. And for today, whoever's in attendance is going to get a little bit of a bonus. This is something I'm working on for a future training video, but we'll do it today so that you guys can get a preview of it, and mainly because, like we mentioned yesterday, we're running out of ideas. So we're going to do a part that's going to be done in a video anyway. And the part is basically like you see here. I have a very simple chamfer on an edge, and I'm just going to do the chamfer. But the challenge is, if we take a look at this from the side, and take a look at the chamfer mill I'm planning on using. Chamfer mill is much smaller than that edge. So today we'll cover how to handle this situation. You've got a tool that's smaller than the chamfer you're trying to do. Normally what we would do is just choose either the top edge or bottom edge and just do one pass, and it's on size and we're done. But since this is larger, what techniques can we use, what toolpaths can we use to actually make a part like this? So I actually came up with two suggestions. One is still using the profile. Let's just open this up and take a look. So the chain I'm using for this profile operation is the top edge. Top edge, bottom edge is usually, I guess, up to your tool definition, up to your preference, how you're going to define your levels in a general chamfering toolpath. Here, I'm choosing the top edge because later on, I'm using, in the advanced section, the wall draft angle. So I'm actually telling it from that edge, add a draft of 45 degrees, because this chamfer is at 45 degrees going inwards. So because I'm using that, I'm choosing the top edge. But the rest of this is still a profile toolpath. It is still a chamfering toolpath. So if we go through here, you can see that I chose my chamfer mill. It's a 3/8 chamfer mill with a 90 degree or 45 degree, whichever reference you want to use. In terms of levels, I chose the top face and this vertice right here. Under technology, it's tool side left. I'm taking it with 100 thou step down. Now that's a step down only because there's more material here. There's some depth to this than the tool can handle. So I'm taking it in steps. Now how those steps are actually going to be realized with that draft angle is basically like that. It's still a Z step. I'm still getting that Z step, but I'm getting it at 45 degrees. Now the only thing additionally that I've done to this part file is after choosing chamfer, this actually becomes the diameter that gets used for cutter comp and for offsets and all that kind of stuff. But if I don't make any adjustments in this section here, it actually will offset it from that face. So what I've had to do is I go in here, and because this toolpath represents the center of the tool and I don't want it to be offset, I've actually put a negative offset there. So that's my 25 thou. That's the offset from that 50 thou I set in the chamfer section. What that ends up doing is getting a toolpath that goes right on the face there. That represents the center line of the tool, which makes sense because I want the center line, I want the tool to match up exactly with that face there. And additionally, I've also added maybe a little bit of a 50 thou on the edge there just to kind of lead off a little bit. But the main thing to look at is that offset there, the negative offset, and this draft angle. I've added some normal lead in, lead out. If we take a look at this in Solid Verify, I roughed it out using 3D machining, and if we kind of slow this down, you can see that it does that face and it cleans it up exactly.
And maybe you want to slow it down just a little bit more.
I wanted to show that it actually completes it. Now I'm going to actually go step by step, but I'm going to actually get a side view of that. So there's the side view. Maybe no. I'll do a host CAD because I think the glare probably really messes it up. So let's just do a side view of that in HostCAD. So stepping through the code, you can see the tool comes down, it goes in, and it's flush. So with that offset and with that draft angle, I'm getting it to be completely flush with that face. Go right down to the bottom. There's my 50 thou right there. Okay. So that's how you can do it with the profile toolpath. You can get it to do that. Now with the profile though, it's still doing all these retractions and it requires a little bit of math knowing your tool size and all that. So another option you can use is HSS. Let me hide this and go into our HSS. Now HSS is a surface-based toolpath, so it's a little different, a little odd to use it for chamfering, but here, because the size of the chamfer, it actually comes in pretty handy. If we use parallel cuts linear, and I select as my surface the actual chamfered surface, and like we talked about the other day, I have it start and full start and end at exact edges, so it's actually not limited by the travel of the tool by the edges of the surface. My angle, because we're in linear, is going to be the y-axis, which is 90 degrees from the x-axis. So that's that guy right there. The tool for HSS, it actually didn't let me use a chamfer mill. But to use the same shape of tool, what I did was I defined a taper mill, because a taper mill is allowed. But if you take a look at my tip diameter, I made it really small. So it actually still kind of looks like a chamfer mill. It looks like it comes down to a point, but it actually has a little tiny bit of a tip diameter with the same angles, so I'm getting that same cone shape.
Yeah, and you guys could use, even though that Mark was using a chamfer mill before, this can also be done like in a spot drill scenario too. So if you just got that one-off part that you need to do, you don't have that taper end mill or a chamfer mill, you can use a spot drill in there, as long as it's on the right material. Obviously, we probably don't want to be tackling this with titanium or any of those harder materials, but so that is
absolutely
optional.
So levels, because this is our HSS toolpath, it's a surface-based finishing toolpath. Again, in levels, there's really no upper level, lower level. I'm just going to leave it at automatic. Toolpath parameters, we'll do that same 100th step down. Sorting, I did a one-way, so I'm kind of recreating that profile toolpath, but using HSS. In modify, I'm doing what we talked about the other day. I'm actually giving it that extension on the tangential edges of the 50 thou. So I'm trying to make this apples to apples with the profile toolpath. Link, I'm adding a lead in, lead out of pretty much a similar amount. I mean, I put 200 thou there. I can't remember what I had in the profile, but I'm basically doing the same sort of thing. And in the links tab, like we talked about the other day, I actually have it set to large moves, safety distance, and rapid. Now I could do clearance area as well, but like we talked about the other day, I think it was yesterday, that almost is a waste of time. So rather than doing what the profile toolpath is doing, I'm actually going to get it to be a little shorter by choosing safety distance and rapid, and with each slice, I'm adding in that lead in, lead out. What that results in is a toolpath that looks like this. So similar number of passes. If we just bring them both on screen, they're both pretty much doing the same number of passes. I think maybe HSS is doing one extra pass on the top there. But you can see that safety distance and rapid is really shortcutting it, so it's actually getting it a little closer. And if we take a look at the toolpath in HostCAD, so my taper mill that looks almost the same as my chamfer mill will come down. In this case, it's just doing a little bit of the top there, so I could actually trim that out a little bit if I wanted to clean it up. But if we take a look at it, it's flush. And that didn't require me to tell it any kind of negative offset. That didn't require me to change anything about my step down, step over, my levels, or anything like that. Essentially, what this is doing is the same thing that HSS is always doing. You can use all kinds of different shape tools and standard shape definitions inside SolidCAM. And what HSS does, it looks at that cutting surface and tries to get it to be tangent. In this case, this can be completely tangent on that one surface. So it actually is doing exactly what I want it to do. It's finding as much of a tangent point as possible, even overlapping a little bit. If I go all the way to the end, the surface is clean. Between those two toolpaths, you have options to do this sort of thing. A smaller chamfering tool, but on a large chamfer surface. Now, chances are, if you have this sort of situation, you might not even bother using a taper mill or a chamfer mill. You might even try maybe using a large diameter ball mill and then just doing multiple cuts to get a better finish. Whatever it is, whatever tool you have, there's a way to do this with HSS. Or if you got the chamfer mill, you can use these two options here.
And maybe
any questions on that?
Let's show them. If we didn't have a chamfer mill, if we didn't have a spot drill, if we didn't have any tool with any kind of, let's show them a toolpath using a ball mill to get that same result, as well as maybe a bull nose. And if If worse came to worse, you guys could use a square end mill. It's just going to take a little bit longer passes.
Yeah. So if you had a ball mill or a bull nose, the programming would be the same. You might have to reduce your step overs only because of the scallop height, but you basically have the same ability. You would choose the surface, that same surface there, because essentially that's what we're trying to machine, so that's what you're choosing. And then the direction, I'm going to keep it at 90. But if we have a ball mill, we can actually go in any direction we want now. But this is just the long direction, so I will keep it in that direction because it's probably the most efficient. Under tool, let's go with our ball mill. So what size ball mill do you want to use?
Let's just go with a 1/4 inch ball end mill because it seems to be a common.
1/4 inch. 1/4 inch. Levels, again, we'll leave it the same. Step over, let's see if we can get a good finish there. We'll do 20 thou for now. If it's a ball mill, we want to have that nice finish. Let's make sure we do one way. And then let's even add those extensions that I had before. So we'll just go in the tangential or essentially the across direction. Take it, 50 thou. Okay. Although probably want to extend that a little bit more because it's a ball mill this time. Let's make it 100 thou. Okay. Let's do lead in, lead out as well. And in the link section, anytime you call out the lead in, lead out, you're really just telling it to use the lead in, lead out. It actually will look at your entry in here, or for this individual use, you can always click on this browse bar here. Instead of using the default, you can set your own individual one for that specific use. So basically what that means is for the lead in and lead out at the beginning and the end, like we see here, the first entry and the last exit, you can set it to a default. And if inside the link section, you want to tell it to use something a little more specific for the linking of slices or the gaps along cut, you can click on those browse bars there and then just set it for that particular use, for the linking, for the lead in, lead out of a link between slices. So you don't always have to use the default. You have many ways to add in some sort of lead in, lead out. Let's do a safety distance and rapid, use lead in, lead out, and then we'll just set this as orthogonal line. So there we go. So one-way cut, a little bit of a lead off on the sides there, and a 20 thou step over. And it goes a little past the bottom of the surface there, only because, again, it's trying to keep that tangent point with the cutting surface. If we look at this from the side, and we bring in our tool definition, since that ball is going to try and finish that point there, the center of the tool has to drop a little bit. Because if I tried to do anything over here, I need to get a tangent point, probably something like that. So you can see that the center of the tool has to dip that low just to do that. And that's able to do that because of this setting over here. And if we want to see that in Solid Verify, we just suppress those tool paths, and then we can go into Solid Verify. And this time, I'll slow it down. Now, starting from the bottom, now if I want to do that, good. If not, I can always go back to my toolpath parameters section and flip. So it actually goes from top to bottom. But this is how you would do a chamfer if you don't have a tool that's at the same angle. You're looking to use a ball mill or a bull nose. You'll get those little scallop heights, but you can account for that.
Let's throw another zinger in there. Let's go ahead and suppress our 3D machining, and let's rough it out and finish it all within that HSS. I know we've kind of covered this before in the SolidCAM Live, but for those of you guys that don't have 3D machining, it also can be done. It's just not the most proficient way.
Yeah, for sure. So let's use the same surface. We'll set this to the second option. And linear looks like it's working for us, so we'll leave it at linear 90. The tool, do you want to rough it out with the ball mill, or do you want to use that roughing tool that I have?
Let's do a flat end mill that you have. Yep.
Yeah, okay, so we got the 1-inch flat end mill. So that's really going to be able to hog out material. Levels, we'll leave it as the same. Step down, this guy can handle some material. So let's put it at maybe that much. We definitely want one way. And let's get a little bit of a lead out on each pass. Let's put this at like 300. Actually, no. 600. Okay, and then we'll make sure that we're using lead in and lead out. I'll put that at clearance area just in case and we'll leave that as that. This guy over here. Now you can see all the stuff I have to go back and change these parameters. I could have easily have just done a save and calculate or a save and copy down here. So that's the point of that checkbox there, to avoid having to do all this all over again. Okay, so we don't need gouge check because we're probably not going to gouge the part. And what Kevin's referring to is this section over here. If you have full HSS, you have the ability to add multi-passes, which are basically your radial step over, your depth cuts, which is your axial step down, and even stock definition. So I can actually trim the air cuts when I put too many passes here. So for instance, let's just do this without the stock definition to start. Let's assume we need maybe like 3 passes with a spacing of ½ inch. And then my depth cuts, let's say we need 3 of those as well with a spacing of ½ inch. Save and calculate. Too many extra passes. That's all going into space, not even really necessary. But if I turn on my stock definition, it recognizes that that's all I needed to machine that stock, just those 2 passes there. Now, in reality, I'm probably going to maybe take this a little lighter. So let's just do 250 and 250. Actually, let's increase those numbers as well, just in case. So put in 5. We probably don't need all 5, but that's what the stock definition is going to help me with. If I don't actually need to do all 5 passes there, I'll just do a save and calculate. It analyzes the stock, and it sees that I probably just needed that much right there.
And if you wanted to, let's go ahead and go to the toolpath parameters and change the step down to maybe like 100 thou or even 50 thou, because that'd be quite the chunk to take off with that bowl. Perfect.
Yeah, and since this is roughing, I forgot, we should probably put some material on the face there. Yeah, so there it is. So that will rough it out. And then that will come in and finish it. And we can take a look at that in Solid Verify.
Now, where that, once this one gets done playing through here, what I have from the past found out is if you guys are doing weldments and this chamfer right here is for a weldment, there's no need to do this nice pretty finish in there because it's just getting filled with weld. So what I would do is either use my HSS or what Mark was already showing us with that, with the profile and the angle, just to get it roughed out in there, and go ahead and just play through just the roughing cycle of that HSS. Maybe Solid Verify that. So now this, even though that we have a very large scallop in here and it's very rough, but if this is for a weldment, our pretty finish doesn't matter at all because we're just looking for a angle of relievement for the weld to fill in there. So that's a nice thing about using that as well. And it all depends on your guys' print. Sometimes when they have a weld, they want a specific surface finish. Sometimes if you guys are just doing it in the house, which we did, that surface finish did not matter to us as long as it was filled up with weld, and then we'd come back over it with a grinder and grind it. You would never even know, and you still get that great weld penetration going on there.
Yeah. And speaking of surface finish, you have the ability when you choose a ball mill to control the scallop height. So if you're given a call out of your RA value or your RMS value, you can actually calculate the height of the scallop from that and plug it in here to get the proper step over for this toolpath to leave behind that finish.
Yeah, that's a great point there, because that scallop is all based off of, like Mark said, the ball. And what you guys can do is RA finish is just a measurement from the cusp to the valley, or no, cusp to cusp. So with that scallop in there, you guys can actually determine what RA finish you will get. So currently, like right now, what are we using, a ball end mill?
Yeah, quarter-inch ball end.
Okay.
So we're getting a.
So we'll be 400 RA finish is basically what we would be getting on this finish right now. So if we wanted, you know, if you guys had a call out of 125, you could just change up your step over to accommodate. So you have that. Basically, what you want is, you know, 0.00125 for your scallop. There you go. So which would come out to a 10th step down for that particular ball end mill in there. Now, that's taken into factor that in a perfect world, there is no chatter, there's no run out, anything like that. That is how you can kind of figure it out. So if you are trying to achieve a RA of 125, maybe you just want to bump that to maybe 100, but so. Yeah, so Brian's asking, so that scallop equals RA, or is there more math than that? So you can do a RA calculation all based off the scallop, but just from using the software for so many years, basically it's 3 zeros and then whatever you want for your RA finish. So if you're looking for, well, I shouldn't say 3 zeros, because if you're looking for a 32 RA finish, it would be 4 zeros and a 3-2, or 24, or whatever you're looking for there. So it's
I think it's just the definition of what RA is referring to, right? So
yep.
So you can always you can look at what the equation is, because usually we work with an RA value or an RMS value, but that's just a metric to measure the surface roughness, which is literally just how high those scallops are. So if you look at the definition of RA or RMS, you'll see in the math that it somewhere is talking about the scallop height. So you can just reverse it. So if you got an RA value, just do the math, reversing it, and then you can get that scallop height and plug it in here.
Yeah, and they actually have RA calculators out there. If you just Google it, you can type in what size ball end mill you're using, what RA finish you're looking for, and at that point, it will tell you the exact scallop that you would need to accommodate that RA finish. Like I said, you guys have to remember, this is in a perfect mathematical world that this would come out this way. So it's not taking into factor, you know, vibration or chatter or run out at that point. And the only reason I say that is because we've run across that with iMachining. Customer will call us up and say, hey, I selected a 32 RA finish, but I'm getting a 48 RA finish when I measure it. Well, like I said, in a perfect world, that's how it is. It's all a mathematical calculation at that point. So yeah, so what Mark's pulling up right there, and you know, the RA finish is all in a mathematical calculation to accommodate that, but it's not taken into, like with Mark's got pulled up right here, it's not taking in machine factors, coolant, run out, all that stuff. So. And so we got, okay, RA is really RA. Yes. Yep. The scallop would be R to Z. Yes. Yeah. Exactly, Brian. So there, I don't know how to word this to get everybody else to understand it, but so what Brian is saying is RA 32 is equals to 32 millionths. And I gotta think about that. Let's see.
I think the way that you worded it earlier is a good way to think of it. It doesn't necessarily mean that you can type in an exact scallop height and then you're getting the exact RA value. A lot of times you're going to have to do a more practical rule of thumb with those sort of numbers. So if you got an RA of 32, sounds like
it's
you were saying
zeros and a 3.2.
yeah, and then that way you're done, right? Because oftentimes you're not going to be able to get it right down to it.
If you guys are looking for a 250 RA finish, then it's going to be what did I just say? 200. I'm trying to think too much. It's going to be 2/10, 5 millionths for your scallop height for a 250. So yes, so a scallop of 0.00125 is a is 125 millionths, but is really RZ rather than RA. I'm not sure what you mean by the RZ, Brian.
RZ, I guess, is like the height of the scallop, right, in the Z or Z direction.
Okay.
I think.
Gotcha.
Because you're talking about a scallop, so the RA is more of a metric of the surface quality, whereas I'm guessing RZ is the
max valley to peak.
Okay, yeah. So then, yeah, so
it's kind of
like I'm trying to describe. So if you look at the geometry of your scallop, it's literally just two arcs, right? So there's the height there, and that would be Z.
Yeah. So what Brian is saying is RZ is the max valley to peak. So yes, Brian, you're 100%. That is going to be the max that it is set up, where RA is the average. And when you take it, and I don't remember what the machine is called, but you stick the little machine on there to measure it, and it takes a sweep over a bunch of scallops, not just one. So to Brian's point, yes, exactly. It's taking that average of all of them. So great questions, guys. Yep. Does that make sense for everybody? I know I got a little thick there, but hopefully that does kind of help you guys out. If you are looking for that specific of a surface finish, it will definitely get you in the ballpark. Like I said, in the mathematical world, that's exactly how you do it, but we also have to accommodate for other stuff.
Yeah, for sure.
That's all I got.
Okay. Yeah. And I think we're out of time. So if you have any other questions, any comments, any parts you'd like to see in the training sessions, Kevin's going to put my email in the chat section. So you can send us your parts, your questions, your comments, anything you'd like to see either here, or if you'd like to do your own personalized training session, you can do that as well. You can use that email to email me with the day and time that you'd like to schedule your own session. We use GoToMeeting for that as well. The difference is you get to use the phone. So you actually can talk to us live, ask questions live and that. If you know anybody that can benefit from SolidCAM, give them our contact info, give us their contact info, give them our contact info. And if they go into a demo, you get that $100 gift card just for them going into a demo. If it goes to sale, you get that 20% of that sale. So you can get a good chunk of money for just doing that. Like I would say, we're continuing this till the end of the month at minimum, maybe past that if you guys really like what you see. So we will continue this tomorrow at 2 p.m. Eastern time. Until then, stay safe, keep your family safe, stay busy. We'll talk to you guys tomorrow.
All right. See you guys.